This is questions 11 and 12 on the diagnostic test. Okay, so continuing our study of radical operations, we have some ones with division of radicals and rationalization of denominators. So a couple things. Notice a lot of these radicals in number 11 have radicals in the denominator. Okay, so that's one rule we have, that in order to be simplified, there can be no radical in the denominator. Okay, so that's not allowed. So, depending on your situation, you have a number of options for dealing with that. First off, let's introduce a rule. So if you have two radicals divided, the answer is the square root of their quotient, and vice versa. Okay, so that means if you can have two radicals like this, and you can divide the radicands, by the way, the word radicand is the number under the radical, or whatever's under the radical. So you'll hear me use that word a lot. If you can divide these radicands 6 and 2, then great, go for it. 6 divided by 2 is square root of 3, and that's all I have to do for that one. Okay, now just like here, when I'm dividing a binomial, I'm going to divide each term by radical 3. So radical 6 divided by radical 3 plus radical 3 divided by radical 3. And again, we're lucky both of these work out. That's radical 2 and plus radical 1, which is just 1. So if I could do it like that, that's fine. And then usually what I'll do is I'll put the whole number first. So you'll most often see it 1 plus radical 2. Okay, so that's the best case scenario. Usually that doesn't happen. So what happens in C and D? Well, let's take a look at C down here. Okay, so for C, if I apply the rule backwards, right, it means that I could take the square root of the top divided by the square root of the bottom. Except that that's going to violate the rule that we set out in the beginning, which is no radical in the denominator. Okay, so I can take the square root of the top, but the square root of 2 is just the square root of 2. Okay, so what do? Well, it's kind of the exact same situation as D, so I'll teach you that technique. But in order to avoid this, there's another way that you can handle fractions underneath. And that is to rename the fraction so that you have a perfect square in the denominator. Then when you take the square root of it, it'll be a whole number. So what if I rename 1/2 into 2/4? Let's neaten this up a little bit. So now we're at the square root of 2/4. I didn't change the value, but look what happened. Now it's the square root of 2 over the square root of 4. Square root of 2 is still the square root of 2. Square root of 4 is just whole number 2. And I've fixed it. I didn't break my rule this time. So what if you are stuck and this is your issue? Well, we're going to learn a technique called rationalizing the denominator. And that comes from the fact that radical 2, square root of 2, that's denomination. Denominator. Okay, square root of 2 is 1.4142135. It's an irrational number. I'm going to make it rational. The easiest way to do this is to multiply top and bottom. So you're essentially renaming the fraction, but your numerator and denominator are that radical. Now, does it have to be that radical? No. It just has to be something that's going to get it to be a perfect square. But if you multiply something by itself, it'll be a perfect square. How about that? And then if I could divide 3 and 2, I would. I can't, so I'm going to leave it like this, 3 radical 2 over 2. That's how you fix that. Now sometimes you have options. Now what if, let's just do a little sidebar here, it was 3 over radical 8. Well, do I have to multiply over radical 8? No. You can rename the fraction. What would make 8 a perfect square? Well, if I multiplied it by 2, that would be 16. That would work. But again, it has to be a radical in order to obey the rule. So that would leave me a denominator of 16, which would end up a denominator of 4. And it would be 3 radical 2 over 4. That's just a little sidebar. Okay, so that takes care of dividing and rationalizing. Okay, so now we have addition and subtraction. So the rule for that is that you have to have like radicals, just like terms. Okay, that means the radicands, see last question, are the same. Then we just add the coefficients. So this is 5 times radical 3, this is 1 radical 3, 5 peaches and 1 peach is 6 peaches, this is 6 radical 3. Don't change the peaches, leave the radicals alone. Okay, if they're not the same, well, you can either simplify one to make them the same, or you can't be simplified. Can't do anything here. So this cannot be simplified any further. Now, if anything here is a whole number, great. Make it a whole number. But do not add these two together. Why? Because would you do this and make 7x? Of course you wouldn't, or I hope you wouldn't, because that would be wrong. It's the same thing. If one of them has a product, whether you're multiplying by an x or a radical 2, if x is radical 2, would be in that situation. So, they're not like terms because 4 doesn't have a radical 2, so please don't put those together. That's a big no-no. Okay, D. Not like radicals, so are we stuck? Not this time. I can actually use my rule of simplification to break down square root of 32, and if it ends up with a square root of 2, hint hint, we will be able to go. So watch what I'm going to do here. So this is 1/2, and now square root of 32 I'm going to break down into two radicals, one of which is a perfect square, and hopefully the other factor is a radical 2, otherwise I'm pretty stuck. Okay, but just so happens 16 is the highest perfect square that goes to 32, and 2 is the other factor. I like to write the whole problem. So that's 1/2 times 4. All this is times, never plus. Don't change it to plus. And is radical 2. These coefficients will multiply together. Half of 4 is 2. 2 radical 2 plus 1 radical 2 is 3 radical 2. Do not add those radicals together. Just like 1x and 2x is 3x. Or 2/5 and 1/5 is 3/5. 2 radical 2, 1 radical 2 is 3 radical 2. Okay, keep that pattern there. So what about E? Can I separate them? What did you get from the last lesson? No, I cannot. So there will be no separating. And why is that? Because of the plus sign. That's right. So don't make that 4 plus 2. So what can we do? Anything? I know. I could add them together. Sums are still sums. Now, can I break this down any further? Sure. But it's gotta be through times. Never by plus. Never, ever, 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 ever. Okay, so highest perfect square factor of 20 is 4. 4 times 5. We can break them apart. I'm just slowing it down. I usually skip that first step. Square root of 4 is 2. 2 radical 5 or 2 square root of 5 is my answer. Okay, but do not split the plus. Don't split across a plus sign. Never, 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 never. Okay, and that's it for 11 and 12.